Hi there. Today we are going to continue solving problems from LeetCode's list of problems called Top Interview 150. Last time we solved the first one, so let's move to the second one. The problem is called a remove element, and let's read the problem and make sure we understand it. So the problem is as follows. Given an integer array nums and an integer val, remove all occurrences of val in nums in place. Okay, so yeah, in place seems to be probably the most important piece of the problem, because we are given an array and a number and we have to remove all occurrences of that number in that array in place. Now arrays don't shrink or expand in most programming languages, so in place probably means that we just compact the array. But let's see what they are saying. The order of the elements may be changed. Okay, that's not a big deal. We could preserve the order, but looks like we are allowed to change the order. Then return the number of elements in nums which are not equal to val. Okay, so yeah, so that's what we do, since we would be compacting, but we won't be literally trimming the array. If there were 10 elements in the array initially and we remove 3 elements, we are not literally removing memory for those 3 elements. Hence, we have to return the logical size of the array after removal of those 3, which would be 7 in the example I gave, which makes sense. Consider the number of elements in nums which are not equal to val to be k, which means there are k elements in the array which are not removed, which shouldn't be removed. So in that case, to get accepted, you need to do the following things. Okay. Change the array nums such that the first k elements of nums contains the elements which are not equal to val. Makes sense. If we are going to remove val, then the first k slots of the array should contain elements which are not equal to val. So they are just restating the same thing again in slightly different words. The remaining elements of nums are not important, as well as the size of nums. So yeah, the remaining elements are not important. Which makes sense. Basically, if you remove 3 elements, then what are the last 3? If you remove 3 out of 10, the first 7 should be the ones that do not equal to val, but the last 3 can be any random value, is what they are saying. That's allowed. And the second thing that is important for our program to get accepted is we have to return k, which means we have to return the number of values in the array which are not equal to val, which are the ones we kept. Okay. They have given some code which is going to judge our code. Makes sense. I think this is where our function seems to be called, and after that they are doing some assertions on to make sure that our code is correct. Okay, if all assertions pass, then our solution will be accepted. Makes sense. Okay, let's look at a couple of examples quickly, although we do understand what to do. If nums is 3 to 2 3 and val is 3, that means we have to remove all occurrences of 3, which means we have to kind of put 2 comma 2, and the last 2 elements could be anything, doesn't matter, but we return 2, which means hey, the first 2 elements is what matters. Makes sense. Here 0 1 2 2 3 0 4 2, and the element to be removed is 2 and the number to be removed is 2, and yeah, after removing 2, oh, looks like they made the order a bit different, but we could just preserve the order as well. So we could also return 0 1 3 0 4, and then dash 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 could be any 3 random values. Okay, I think we understand the problem enough. There are constraints. I think they are pretty much yeah, none of them really are going to be that useful in simplifying our code, in my understanding, but yeah. So okay, so in order to understand the approach before we write any code, the approach that we should that I want to take is pretty simple actually. But in order to understand the approach, I want to take an example where we are actually creating a new array for the result, and just to understand, or a new list. So let's say this is our input array, and we want to copy all the elements from this input array which are not equal to 2, so val is equal to 2, into the result array. And imagine that result array is already allocated to have enough space, right? So in this case, 1 2 3 4 5, I think, yep, 0 1 304. Yep. 1 2 3 4 5. Yeah. So the approach would be very simple, right? We would start with a source pointer and a destination pointer. Source pointer will start pointing to the first element of nums, while destination will be at the first index of result. And if the element at the source pointer is not equal to 2, then we are going to copy it at the destination pointer and move the destination pointer forward. So the destination pointer moves here, and source pointer always moves forward. So source pointer moves here. This is also not 2, so we again copy it where the destination pointer points, but move the destination pointer forward. Source pointer again always moves forward. Now source pointer is at 2 and that is equal to 2, so we don't have to be copied. So source pointer moves forward, but this time destination pointer stays here because we haven't copied anything. Same with this 2, we are going to skip and go to the next 3. So source moves forward, destination stays there. Now we see 3, so we say, okay, hey, that is not equal to 2. Copy into where the destination points, move the destination forward, and so on. So if you see, this approach is pretty simple. It will create the right output array or list, and it will work. Now, but we have to do this in place. So we might wonder, how could we do this in place? It turns out, actually, if you work out a couple of examples on a whiteboard or on a piece of paper, that the same approach actually works in place by doing exactly the same thing. And the reason is because imagine you don't have this. So let's kind of just do a quicker version of what we just did in place. So our source pointer is at 0 and destination pointer is also at 0. Now, since what we are reading at source pointer is not equal to 2, we want to copy it wherever the destination is pointing, which in this case is itself. Now, same thing will happen with source will move forward, destination moves forward. Now they both are still pointing to the same element. Again, that is not 2, so it will be copied on itself, which is fine. Now source is at 2 and destination is also at 2. But since this is a value that we don't want to retain, we are going to move source forward. We are not going to move destination forward because it is equal to 2. And that is how this 2 will get overwritten by whatever is not 2 later. And that is why it automatically just works. The same approach works in place as well. In order to figure out how many elements we did, or how many elements are going to be actually not deleted logically, the destination pointer's value at the end of it should actually give us that count, right? Because we will be incrementing it only as many times as we keep or copy a value that is not equal to val. So that's the approach. I think hopefully it makes sense. It's pretty straightforward. It turns out it preserves the order of elements that are not deleted, but which we are allowed to reorder, but we don't have to. So we are going to do that. Let's do it. So like I said, we need a dest index. Dest pointer in arrays is just an index which starts at 0. And we always move a source pointer by 1, so I would rather do a for loop for that. There you go. And our logic, like I said, is very, very simple, right? If we say if the element at source index is not equal to val, then we do nums of dest index equal to nums of source index. We copy the element at the source index into the destination index, and we increment dest index. And remember, source index is already incremented by the for loop, and that's kind of nice. We don't have to worry about it. And that is it. I think if you think about it, like pretty much all the parts we talked about in the high level logic are done. Now the thing is, we have to do this now. We have to return the dest index, which is like which will be actually the number of elements which are in nums which are not equal to val. And because it starts with 0 and would have incremented by 1, it kind of works out because after the last increment, it actually holds the count of the elements which are not equal to val. The only thing I want to do is I want to kind of run through a case where let's say everything in nums was equal to val, right? And make sure that dest index actually makes it work. So let's say that nums is equal to 2, 2. Okay, so The example I'm running through is nums equal to 2, 2 and val is also equal to 2. In this case, we should be returning 0. So dest index is 0. Source index is going to start with 0. And we are going to say, hey, is it equal to val? It's actually, it is equal to val, so it's going to just not increment dest index at all. Move to the next element, which is this guy, and it is still equal to val. It's not going to increment dest index again, or not even going to change anything in the array, but it will say that, hey, there are only 0 elements which are not equal to 2 in this, and that is why. And like the problem said, we don't have to worry about what is after the first k elements in the array, so we don't have to zero out the 2's or anything like that. Okay, that is all. I think I'm ready to run this, so let's do that. Okay, looks like I made some small compiler. 1 second. Oh, nums.length source index equal to 0. Yeah. Okay, looks like it got accepted. I do want to add the test case that I manually ran through as one more. So let's just make it like 3 and 3, and let's see if this works. All 4 3 should be removed. I mean, at least it will, yeah, logically remove. That is all actually. There is nothing more to this problem that I can think of. The complexity obviously is O of n. We are going through the array once, and that is all. Hopefully that was clear to all of you. See you next time.